We always talk about AI as like this purely logical thing, right? Just going after goals, even being kind of ruthless about it sometimes. But what if I told you researchers are actually working on how to give AI altruism?
Altruism, like the ability to care about others.
Exactly. Pretty wild, huh? If you're into these deep dives into the crazy world of tech and, what it means for us, well, hit that subscribe button. It really helps us keep exploring these big questions.
It's definitely an exciting area of research. I mean, think about it. We're building these insanely powerful systems, and as they become more and more autonomous, we got to make sure they're working with human values in mind.
Yeah.
Right now, most AI is all about optimizing specific tasks. They don't really think about the bigger picture, like the impact on people or even the environment.
Yeah, totally. And that's what we're going to dig into today, right? How do we go beyond AI that's just focused on its own little goals? How do we build systems that actually care about us, that make ethical choices and maybe even like look out for each other? Because as you said, things could get messy if we don't figure this out as AI becomes more, well, everywhere.
Think about it this way. Imagine an AI that's supposed to manage traffic in a city. Its main job is to reduce congestion, right?
Right.
But if that's all it cares about, it might decide to reroute all the traffic through neighborhoods at 3 a.m, totally ignoring how noisy that would be for the people living there.
Oh, for sure.
It just wouldn't have that basic consideration for others that a human traffic planner would.
Okay, so what's the mission for this deep dive? What are we really trying to wrap our heads around here?
We're going to explore a super interesting new approach. Scientists are trying to give AI agents something called considerate self-imagination and a theory of mind, or TOM for short.
Theory of mind for AI. Okay, that's new.
Basically, the idea is to give AI the ability to run simulations in its head, play out different scenarios and understand how its actions would affect others. And then it could actually make decisions that prioritize things like altruism and avoiding negative consequences.
So it's kind of like how we humans get that other people have their own thoughts and feelings, right?
Exactly.
Like we can kind of predict how our actions might make someone else feel or what they might do next.
Precisely. And this research is totally inspired by how that works in humans. Our altruism, it's not just about random acts of kindness. It often comes from empathy. Our ability to understand what's going on in other people's minds. We use our imagination to play out different possibilities and figure out how our choices might affect the people around us.
You mentioned an interesting example earlier, the Chinese story about Sima Guang and the vat.
Oh, yeah.
Can you tell us that story and why it's relevant to what we're talking about?
Absolutely. So the story goes, this young boy, Sima Guang, was playing with some other kids near a big water vat, and one of the kids falls in.
Oh, no.
Without even thinking, Sima Guang grabs a rock and smashes the vat, letting all the water out and saving the kid's life.
Wow.
Now think about that for a second. He made a split-second decision to prioritize saving a life, which is like the ultimate altruistic act.
Yeah.
Even though it meant destroying property, the vat itself.
Right.
It's such a simple but powerful example of how we weigh different values and act on the one that matters most in that moment.
Yeah, I see what you mean. It's not just about doing something good, but also about thinking about the potential downsides, right?
Yeah.
And making a judgment call about what's most important. It kind of reminds me of Asimov's 3 laws of robotics. That early attempt to program ethics into AI with that famous first law, a robot may not injure a human being.
That's a great connection. Asimov's laws were definitely a huge starting point, a way to begin grappling with AI ethics. But the real challenge is figuring out how to translate these big ideas into something an AI can actually use out in the real world, where things are messy and unpredictable. How do you even define harm in every possible situation?
Right.
It shows us that we need to go way beyond simple rules.
Okay, so this research wants to go deeper than just setting rules. It's about giving AI something like an internal ethical compass. How does this considerate self-imagination and theory of mind thing actually work inside an AI?
The basic idea is to put this theory of mind ability into what they call the AI agent's imaginative space. It's basically a simulation environment inside the AI's head, where it can mentally try out different actions and see what happens. By adding a TOM mechanism, the AI isn't just calculating outcomes for itself.
Gotcha.
It's also trying to guess how its actions would affect other agents. In this study, those other agents represent humans who might be trapped.
So it can run these little what-if scenarios in its head and kind of sense how things would ripple out and affect others.
Exactly. And the really cool part is that it encourages the AI to weigh a bunch of things at the same time. its own goals, potential altruistic actions like rescuing someone, and also minimizing any negative side effects on its surroundings. The researchers want to get away from just rewarding AI for doing good and punishing it for doing bad.
Right, I see.
They're trying to cultivate intrinsic motivation, a natural tendency to be considerate and avoid causing harm.
That's a big shift from how we train AI now, where it's
Yeah.
all about chasing those external rewards.
Definitely.
What are some of the older ways people have tried to make AI safer or more altruistic, and what were the problems with those?
Well, there's been a lot of work in AI safety, trying to prevent unintended harm, like an AI optimizing a system in a way that ends up hurting the environment. And there have also been efforts to encourage, helpful behavior. For example, some researchers have tried to carefully design reward functions that incentivize safer actions or reward the AI for helping other agents. There are even approaches based on the brain, trying to copy the neural mechanisms we think are involved in empathy.
But this new research is saying those approaches aren't quite enough.
Yeah, the limitations pop up when you get these conflicting situations, like what happens if helping someone might cause a little environmental damage?
Right.
Or what if avoiding any possible harm means the AI can't achieve its main goal? These older methods, they don't really give AI a way to handle those tough ethical choices. For example, an AI that's only focused on protecting the environment might not save a human if it meant taking even a tiny risk of environmental impact.
That makes sense. So this new framework is giving AI a more holistic view, helping it balance those ethical trade-offs. Can you walk us through how this self-imagination module actually works, computationally speaking?
Sure. The self-imagination module is basically a learning mechanism that lets AI use its past experiences to predict the outcomes of its actions.
Okay.
As the AI interacts with the world, this module updates its internal models. But the really innovative part is that they've added perspective taking inside this imaginative space. It
Interesting.
uses that theory of mind mechanism. This means the AI can try to simulate a situation not just from its own point of view, but also from the perspective of another agent.
Oh, cool.
It's like it can try to understand what that other agent might experience.
So it's this internal simulation and being able to see things from another perspective that creates this motivation for altruism without actually needing to be told to be good or rewarded for it.
Exactly. By imagining how its actions might affect others, the AI develops this inner drive to help them, to avoid causing harm. And it does this all while still trying to achieve its own goals and minimize any negative impact on the environment. It's like building consideration into the AI's decision-making process.
To really test this out, the researchers built this smash vat experimental environment, which, like we mentioned earlier, sounds like it came straight from that Sima Guang story. Can you describe what this environment is like?
It's like a virtual grid world. It has walls that block movement, a goal the AI agent needs to reach, vats that can be broken, the AI agent itself, and importantly, other agents that represent humans who might be trapped inside those vats. The AI has a few actions it can choose from: move up, down, left, or right, smash a vat next to it, or just do nothing.
And the possibility of a trapped human, that's key to testing the altruism, right?
Absolutely crucial. One really important detail is that if any agent, even the AI itself, goes into a vat, it's stuck there for the rest of that training round. This lets the AI experience being trapped, so it can start developing something like empathy.
So what are the rules of the game? How does the AI get rewarded or punished for its actions?
The reward system is really simple. It doesn't directly reward altruism or punish harm. The AI gets +1 point when it reaches the goal, and it gets a tiny penalty, -0.01, for every step it takes. This encourages it to be efficient. But here's the important part. There are no rewards for avoiding smashing empty vats or for rescuing a trapped agent.
Interesting.
So any behavior that shows consideration for others or the environment, that has to come from the AI's own internal motivation developed through that imagination process.
Clever. That's a great way to see if this intrinsic motivation is really driving the behavior. They also created a bunch of variations of this smash vat environment, right? Each one more complex than the last. What were some of the key differences they were testing?
They designed a bunch of different environments to really poke at different types of conflicts. Like some focused on the trade-off between avoiding the bad consequences of smashing a vat and the agent's main goal of reaching the end.
Okay.
That might force the AI to take a longer route. Other variations added the element of a human being trapped inside a vat.
Right.
So now the AI has to balance its own self-interest with avoiding damage and the chance to be altruistic and rescue someone. They gave these environments pretty descriptive names, like basic VAT goal M, basic human VAT goal M, side human VAT goal M, stuff like that. Each one was designed to test a specific ethical dilemma.
And what happened when they trained their AI agents with this new method? What kinds of actions did they see?
The results were amazing. They saw that the AI, trained with this considerate self-imagination and theory of mind, it consistently prioritized saving those trapped humans. It would smash the VAT if it had to, even if it wasn't the fastest way to the goal. But when there was no human trapped, the same AI would actually take a longer path to avoid smashing empty VATs.
Ah,
It clearly learned to avoid unnecessary damage.
that's a really cool balance. They weren't just smashing everything in sight to save someone, but they also weren't so scared of doing something wrong that they wouldn't help.
Right.
Can you give us like a specific example from one of those test environments?
Yeah. Let's take a look at the situations they labeled A and D. Those were environments with no humans around. In those cases, the AI would always take a longer route to avoid breaking the empty vat in its path. That shows it learned not to cause unnecessary damage. Now compare that to B and E, where a human was trapped inside the vat. In those situations, the AI immediately smashed the vat to rescue the human, even if it wasn't the most efficient way to reach its own goal. And in even more complex scenarios, like C and F, the AI even took big detours to reach and save the trapped human. It really suggests that its actions were driven by this, empathetic motivation, not just a desire to clear obstacles. They even found a case where the AI chose a slightly longer path, but it smashed a vat from a specific angle to avoid also smashing an adjacent empty one. A super smart decision that shows real careful consideration.
So this method is actually leading to more considerate behavior. That's pretty cool. How did their approach stack up against more traditional ways of training AI?
They compared their method to two other things. One was the standard deep Q network, or DQN. It's a super common and effective reinforcement learning algorithm. They also compared it to something called empathy DQN, which was an earlier attempt at adding empathy into AI. Now, the standard DQN, it just wants to maximize its reward by reaching the goal as fast as possible. It completely ignored avoiding damage and rescuing agents. Empathy DQN could do some rescues, but it also tended to smash VATs unnecessarily to speed up.
Oh, interesting.
And it really struggled in situations where rescue meant taking a detour. But the researchers' proposed method was the only one that consistently did all the right things in every single test environment.
That's awesome. And they had actual numbers to back this up, right? Like the average number of unbroken VATs and the success rate of rescues.
Yeah, totally. Their data showed that their method did way better than both DQN and empathy DQN. In environments where no one was trapped, their AI kept way more VATs intact. That means it was much better at avoiding damage. And in the environments with humans trapped, their method saved way more of them over time. They even pointed out times when the DQN might have accidentally rescued someone, but it was more like a lucky coincidence than an intentional act. And the empathy DQN's rescues, they really suffered in those complex detour scenarios.
They also did an ablation study
Right.
where they take away parts of their method to see how each part contributed to the overall performance. What did they find out?
Oh, the ablation study was super insightful. It showed what those two key parts of their approach were doing: the penalty for causing negative side effects and that empathy incentive. What they found was if they only gave the AI the reward for reaching the goal, basically like a standard DQN, it just ignored everything else. No harm avoidance, no rescues. If they added the penalty for negative side effects but no empathy incentive, the AI learned to avoid smashing empty VATs but wouldn't actually try to rescue trapped agents. And the opposite was true too. If they only included the empathy incentive, the AI would rescue but wouldn't avoid unnecessary smashing in environments without humans. It was only when they combined both elements, their full method, that they got the perfect behavior, rescuing when needed and avoiding harm when no one was in danger.
Makes sense. You need both the don't do bad stuff and they actively do good stuff motivations working together. They also looked at how sensitive their method was to specific settings, right? Like changing some of the parameters.
Yeah, they did a hyperparameter analysis where they tested different values for those parameters that controlled how strong the penalty and incentive were. It was great to see that their method was really robust. Within a reasonable range of those values, the AI always showed the good, considerate behavior. But they did notice that if the parameters were set too low, the AI might focus more on reaching the goal quickly and might end up smashing VATs unnecessarily.
That's really cool. And they even tried their approach with a completely different kind of neural network, right? One that's based on the brain called spiking neural networks, or SNNs. What'd they find there?
That was a super interesting result. They found that their intrinsic motivation thing worked incredibly well, even with SNNs. The performance was still awesome. This suggests that their approach isn't limited to just one type of AI structure. It's more like a general principle for building in these intrinsic motivations. And they even talked about the techniques they use to train these spiking networks. They're actually inspired by how real neurons in the brain talk to each other using these little spikes of electricity.
So big picture, what were the most important takeaways from this research?
I think there are a few big ones. First, they've come up with a brand new way to try and align AI behavior with human values, specifically altruism, by giving AI a form of self-imagination and theory of mind. Second, this framework seems to be really general and could potentially be used across a whole bunch of different AI tasks and areas. Third, they created this ingenious smash-fat environment that's a really rigorous and clever way to see how well an AI can balance conflicting objectives like self-interest, altruism, and avoiding harm. And finally, the experiments show that their method can actually lead to AI agents that prioritize rescue, avoid unnecessary damage to their environment, and still achieve their main goals.
So it seems like we're seeing a step, even if it's a small one, towards creating AI that's not just intelligent in the, computer science way, but also considerate of others. But of course, with any early research, there are going to be some limitations. What were some of the things the researchers pointed out?
Totally. The researchers are upfront that this smash-fat environment, while super useful, is still a simplification. The real world is much more complex and unpredictable.
Right.
And their current way of doing empathy, it's based on that shared experience of being trapped, which is super basic compared to the full range of human emotions and moral reasoning. So this is definitely progress, but it doesn't mean AI suddenly understands human ethics on a deep level.
It's more like a functional version of altruism.
Right.
In a controlled setting. So what are some things that could be done in the future with this kind of research?
There are some really cool directions for the future. One big thing is to create more complex environments with more conflicts to really push these AI altruism mechanisms.
Gotcha.
They also suggested using more powerful AI tools, like large language models,
Oh, wow.
to help the AI understand and align with human values even better. Imagine an AI that could actually reason about ethical dilemmas using language and a deeper understanding of context and intentions.
That's pretty mind-blowing. This deep dive has really got me thinking, could giving AI this basic ability for imagination and a simple form of empathy, even at this early stage, be a major step towards creating AI that's not only super capable, but also fundamentally trustworthy and beneficial for society? It makes you really think about the ethics of how we develop these powerful technologies.
Absolutely. It brings up huge questions about the nature of intelligence and the values we want to see in the AI that'll shape our world. This research gives us a glimpse into a possible future where AI might not just be super smart, but also naturally inclined to act for the greater good.
It definitely gives you a lot to chew on. If you enjoyed exploring the altruistic side of AI, hit that subscribe button and share this deep dive with anyone who's curious about the future of AI and human values.
Yes.
We'd love to hear your ideas for future topics, so drop them in the comments below.
Definitely.
Thanks for joining us for this deep dive.